Upcrossing index is a tracking parameter for validating a pulse-type shaft speed measurement. It is defined by this equation as the maximum value of the ratio between previous upcrossing period and current upcrossing period within a processing data block. Upcrossing index tracks the rate of change of all upcrossing periods from shaft revolution to revolution. If speed measurement is corrupted and causes a false pulse, or missing a true pulse, then upcrossing index can detect such corruption. As a rule of thumb, the normal range for upcrossing index is between 50% to 150%. Any crossing index outside this normal range could indicate bad speed data. For example, the first plot of this reference window shows the RPM profile of a test. Let's bring up the reference window menu. Its RPM is generated by using time domain RPM tracking from its speed measurement. Block size 1024. 1 pulse per revolution. And threshold level for upcrossing is 2. Since the upcrossing index is turned on, it is shown in the second plot of the reference window. Now notice that there are a few places where the upcrossing index are outside the normal range of 50% to 150%. These include the beginning of the test and the end of the test when RPM is very low. Also these two particular times around s plus 60 second and s plus 110 second. To take a closer look, let's generate the time history of its speed measurement at the beginning of the test. Due to the very low RPM during initial startup, the block size of 1024, which equates to 0.4 second, is not big enough to include at least 2 revolution or 2 upcrossing events for RPM calculation. Therefore, its RPM and upcrossing index are not accurate. Same thing at the end of the test. Next, let's take a closer look at the first high upcrossing index. Drag around it around s plus 60 second to capture the time frame and generate its time history. Further zoom in. As can be seen here, there is an extra spike which could be due to measurement corruption. This extra spike causes its upcrossing index to jump to 300%. Next, let's drag around the second high upcrossing index around s plus 110 second. Then generate its time history. Further zoom in around this time with some abnormal waveform. As you can see, there is a spike whose amplitude is substantially lower than all other spikes. Since its amplitude is lower than the threshold level of 2, it misses a valid upcrossing count. And as a result, causing its upcrossing index to jump to 200%.